Hello, I'm Pam Hoffman, Everyday Spacer.
I'm Jeff Miller, 2049 Outfitters.
At Everyday Spacer, we show regular folks how to personally and directly participate in space exploration, science, and astronomy. We're here on Friday nights at 9 p.m. Pacific Time, 12 midnight Eastern Time, and 12 noon on Saturday in Hong Kong. We're broadcasting live from Thousand Oaks, California.
If you like this video, please subscribe and hit the like button. Thank you. And congratulations to the OSIRIS-REx sample return mission. Welcome back to Earth. The capsule brought back 250 grams of material from the asteroid Bennu.
Yeah, Scott, more rocks. All right, before we get started, I wanted to take note of a comment received on the Particle Physics Basics episode recently. Are you sharing it or should I?
Oh, yeah.
I'll share it. There it is. I want to start by saying thanks to Dawn because she left a comment too. Right here. We really appreciate that. Then this. Oh, hey, Cliff.
Yeah, hi, Cliff.
Cliffy is here. Yay, Cliffy is here. All right. And then we got this comment from Kush6827. And Kush wrote and offered some feedback. So I was answering, hey, anything we can help you with? Well, given the complete incoherence of this video content, I seriously doubt it. So what I said was, please join us and help us do better. We have open dates October 13th, 20th, 27th, and beyond. We'd love to share our live. Send me an email at pam@everydayspacer.com and we'll get you set up.
And so far, no reply.
Nope, but that's fine. So, go ahead and come back to us.
Okay.
Yeah. Oh, we got Nor?
Yep.
Hey, Scott. Welcome. Does he talk about the... Yeah, it was kind of... I remember you said that.
Yeah.
So, we do love feedback, and it helps us improve, and it enhances our show when you give comments and that sort of thing. Remember this, though, particle physics is not my area of expertise. It's something I like. So I read about particle physics for fun. I can't say it, but I can read it. I don't know about you, Jeff, but I tend to leave some gaps in what I tell you on purpose to pique your interest. If you notice something missing, you might go looking to satisfy your curiosity. And that's the whole point. We show you how to personally and directly participate in space exploration, science, and astronomy. And Scott is a perfect example, counting rocks on Bennu, even before the return mission. When was that, Scott? That's been a while, right? Mm-hmm. We do love to share our lives, so please, Kush6827, we encourage you to come on our show as a guest or make a rebuttal. I know you have a YouTube channel. I don't see any videos there yet. Let's have a conversation. I'll probably never be an expert in particle physics. I do love learning about it, and I'll probably take it as far or as little as I want, and that's my hope for you as well. Delve into the things as much or as little as you want because you love it. Last week's trivia question was, what are darkons?
And before we get to that,
yeah, Big Moon.
Yeah, Big Moon. Of spending a little time learning with you all. Oh, good.
Thank you, Janie. Welcome. We're so glad you're here. Last week's trivia question was, what are darkons?
And no one actually took a stab at this, but it's an old theory basically about optics that does not work in physics. Basically, if you take the optics equations and basically flip the pluses and minuses on things, you end up with darkons, which are absorbed by things like the sun and light bulbs and emitted by matter.
Was it a science fiction?
They've used them in science fiction, but it was originally just proposed by some grad student somewhere as a thought experiment, and it works great except when you involve physics.
I see.
Then it doesn't work. But darkons amused me because I don't like light very much because of my eyes. Yes. So I just thought that they were that you want to get rid of things that are stealing the darkons from the universe, like light bulbs and things.
We have more comments I see, so
Yeah.
let's.
Scott, one of the things I love most about this show is that you two are willing to tackle a very wide range of science topics. Yeah.
Well, thank you, Scott.
Yeah. Thanks. Yeah. We don't.
Well, we really like this stuff, so that's what we do.
And, we don't necessarily claim to be experts on any of them.
No.
And, like this Tonight Show. But, hopefully you'll learn something. If
we
something
sure as
piques
hell
your
do.
interest. Yeah.
Every single time.
And we try to give you the link so that you can go find it yourself too. And maybe learn more about it. Yeah. And Dawn.
Hey,
hi, Dawn.
Dawn, welcome. I'm so glad you're here. All right, so we do have another crunchy topic tonight. It's dark photons. We'll be back in 8.3 seconds. Jeff saw an article about dark photons and it intrigued him, so he did some digging. Tonight we will discuss dark photons. What are they and how do they relate to dark matter? How do they relate to dark matter, Jeff?
Well,
and this is you, right?
Yeah.
Tell me when you're ready.
Go for it.
Okay.
Well, actually, that's good. Well,
okay.
But first, Cliff. Yeah.
Oh, hey, Cliff.
What will they find out now and in the future teching those rocks?
Yeah, they're rocks, but yeah, it'll be interesting, I guess.
As long as it's not some fungus that takes over people and makes them eat people's faces off.
Yeah, I could agree with that.
But okay. So I saw this article on dark photons, and just because I remember darkons, it just kind of piqued my interest.
I think it gave you a giggle too, right?
Yeah. Dark photons always have. And so this was just like related to that.
Yeah, I'm not sure I've ever heard the term dark photons before.
I think it's fairly new.
Per se. Okay.
I think it's fairly
new.
All
right. Okay.
And basically the premise was that dark matter since dark matter does not interact with normal matter and photons, there has to be something that transfers energy from one bit of dark matter to another. Okay. And so they proposed, well, let's call them dark photons.
Not darkons?
Okay. Right. Well, yeah. I mean, it would have been great if they'd called them darkons.
And funny.
Either it never occurred to anyone, or it occurred to someone and some senior professor somewhere said, no. It could go either way. I'd be more impressed with the latter. No.
It's the computer guys that come up with weird things for their...
Oh, you haven't met grad students.
Oh, okay.
Some are like super serious and, and haven't yet done experiments on a sense of humor.
Okay.
But so sorry, folks. So dark photons. Here, let's just get back to the article. Basically proposed. Oh, that's right. I can't scroll that. I have to scroll this.
Yes.
Okay. There we go. Now it scrolls. Hey, look at that. It's scrolling. Okay. So
it's constant. It is.
But so dark photons were created to fill a hole. And so they were created kind of with certain parameters.
You're saying to like fill a gap in the explanation of the science, right?
Yeah. And
okay.
And let me be here. Let's bring us back to
okay,
this.
Sure.
Yeah.
Because he's probably going to do some of this.
Yeah. Okay.
Making furtive gestures with his fingers. Is that how that goes? In this? Okay.
Yeah, you have to do it in this accent, though.
Oh. Okay.
But
I'll work on that.
I've never been a huge fan of dark matter as a concept because it feels too much like a fiddly bit that's added onto a theory to make it work when it doesn't match reality.
Well, it's a real thing. I don't like the name dark matter.
Right.
It's a mass anomaly.
Well, but it's a problem with the theory. that they're trying to spackle over. It's kind of like the Earth-centric universe when they plotted out the circular orbits of the other planets,
Yes.
and they ended up with these fiddly bits, circles on the circles.
Lots of fiddly bits.
And then they had to have circles on those circles, and it just basically you have to keep adding fiddly bits to make your bad theory
make it all work together.
Yeah. And it happens so many times that I've never seen a theory that's good be enhanced by putting fiddly bits on it.
Well, and that one wasn't
right.
That wasn't good either.
Because
along came Copernicus and screwed it all up.
And it means
gave us the proper.
Yeah, well, they had the signs. The fact that they needed the fiddly bits gave them the signs that so there was something wrong. And it
so we can use that. We can use that in cases like this, maybe.
Yeah, and Einstein added a fiddly bit to his equations when he added the universal constant, just basically to make it the equation so that the universe was static, because that fit his preconceived notion.
Mm-hmm.
So dark matter.
But there's theory, and then there's proof.
So orbits aren't, basically galaxies are not rotating the way they should with our current known physics. So they added dark matter.
JD says Fiddly Bits is a good name for little candies for Halloween.
Mm-hmm.
Yes.
But,
I like it.
Yep. So, so to me, dark matter has always been a fiddly bit that they tacked on just to explain why their theories of gravitation don't work with galaxies. So, and
AC's back. Hello. Are dark photons related to
I don't know.
Majorana neutrinos? I haven't heard of Majorana neutrinos. I know about because neutrinos don't really have a mass, but they are very swift. They give them a virtual. Well, the idea is that maybe there is a virtual mass to them because of the speed. So if you have more on that Majorana, I would love to hear about that.
Yeah.
AC.
Now,
thanks for joining us.
I'm not saying that dark matter doesn't exist. It's quite possible it does.
Something's going on.
I know. It just makes me think that because of the total lack of actual evidence.
But that's what proved it. It was the evidence that they're not.
Right.
The galaxies aren't
spinning
around because of the mass it has. They're spinning around because of the mass and more, like lots more. Some 90+% more.
Right.
That we don't know what the hell it is. I mean, we literally don't know what it is.
Right. But dark matter as a thing, okay, I guess the authorities have said that dark matter is safe and effective, but
that's you did it.
Yes. You're trying to make it so that I wouldn't, but
nope.
I managed to get it in there. But
no, I said I gave you the green light. I said do it.
Yeah.
And you did.
Yeah.
I thought you'd forget.
I have a mind like a steel sieve.
Yes.
But
we both kind of do.
Yeah.
Although his is better. His memory is better than mine.
Yeah. Now, here.
AC comes back with, but neutrinos do have mass.
Yeah, they do.
Oh, okay. See, this is new to me. I haven't looked at it lately. That's why they can change between electron, muon, and tau neutrinos. I better look into that. Thank you, AC.
Yeah, I think we covered that in one of the Zooniverses.
Oh, okay.
As they were talking about how they change. And
okay. All right.
So, can you put it back on the shirt with us? Okay. Don't remove it. Yeah, thank you. Okay. So, getting back to dark photons. One of the things that dark photons have going for them is that, and I don't know where in this article it is, but there's a reference to this wiki page. The dark photons actually explain something that we're seeing wrong in the way muons react. So it kind of like they made it to fit the the gaps in, dark matter, but it also does explain something in other parts of physics too. So
Okay.
that's what makes it more likely.
AC is back with, it's just very small mass, maybe only a fraction of an electron volt.
Yeah.
Okay.
But there's lots of it.
There are a lot of neutrinos, right?
Yeah. And neutrinos were one of the possible explanations for the missing matter.
Yes.
But they looked at all of the sources that are producing neutrinos and just decided that there weren't enough neutrinos being produced.
Oh, okay.
So.
And I gave a talk on this many years ago because I wanted to, when you commit to doing a talk, you have to come up with the goods.
Yeah.
And so that forced me to learn. So, yeah. That was the point. Way back to your.
Yeah. So, okay. So one of the good things about the dark photons is that you don't have to mess too much with the standard model in order to, is that you don't have to mess too much with standard theory to, in order to basically slot dark photons in.
Okay, one moment, please. I have to deal with this. Let's go to that, and then one of these. And hello, thanks for being here.
I think your keyboard has a problem, though.
Nope. I figured out what's going on.
Okay.
Oh, I did it wrong. Oh well. Yeah. Thanks, Scott. You saw what happened. Yeah, we encourage people coming and saying hi. We really appreciate that. We don't really show some of the more unpleasant things, though.
Yeah.
So thanks, Scott.
Yeah. So
go ahead, Jeff. Sorry.
So here we are on the wiki page, and I'm going to share both of these a little bit later into the comments. And it's very, gets into a lot of the math, and some of you might know what this actually means. I dug into it a little bit, but kinetic mixing between photons and dark photons.
And
I
don't know what that one is.
And so they're actually searching for dark matter now in particle colliders.
Okay.
One of the theories is that a hadron collider, using, hadron collider will have a chance of showing dark photons or dark matter. Just because if things don't bounce the way they're supposed to, that leaves, and if they don't bounce the way they're supposed to in just the right way, it means dark photons are a likely explanation.
Okay.
So they're looking for that, and one of the problems is that they had trouble determining what the photons were doing in their observation equipment, but they managed to find a way to capture the photons in individuals so that they can count photons that are being produced. And by judging by the count, have a clue as to whether dark matter. So they might actually have a way to determine that there's something out there that's prevalent.
Okay.
And if they want to call it dark matter, cool. But the heavy photon search is what this is. And what's that? Okay, go for it.
Oh, okay. So thanks, AC. I was just reading about this. A main evidence for something like dark matter is the gravitational lensing by galactic clusters that don't appear to have sufficient visible mass to account for the observed magnitude of the lensing. Yeah, like I said, I was just reading about that. Thank you very much. We seem to have a spammer, so I'm going to do my best to basically put them in a timeout. I don't mind people coming and talking to us. This is not what that is. So we're a little distracted. I'm very sorry about that. Because we keep getting, I think it's probably the same person just creating new
accounts.
new ways to, to mess with us.
Yeah. So
it's kind of a good sign though, because somebody wants to mess with us because, we're making a difference.
yeah. So now I did find out some things about dark matter itself. This has nothing to do with dark photons,
Okay.
but they've been doing surveys using gravitational lensing and other observations, and some galaxies move slow enough that they don't appear to have dark matter in them, and some, through gravitational lensing, appear to be patches of dark matter with no visible matter in that patch. So maybe a galaxy's worth of dark matter with no visible galaxy there. And so whatever theory that they have for dark matter, either these observations are wrong and could be a statistical anomaly, or there has to be a thing of you have to explain why dark matter can but doesn't necessarily have to be in a galaxy.
Okay.
If we've got galaxies without dark matter and dark matter without galaxies, then they have to explain that. Now, if they're gravitationally attracted, then yeah, I mean, it makes sense. But it also makes sense that every once in a while there's one or the other that's not near one. Like there's matter that's not near dark matter, or dark matter that's not near matter. So they're not attracted to to commingle. So it appears to be fairly rare that happens, but they have found it.
The thing for me is, isn't it wonderful? There's so many mysteries.
Oh yeah.
Still to keep working on.
And dark. I had a thought, but I lost it.
It'll come back.
Oh, yeah. One possibility, and I had this thought when string theory was still around, is...
You mean it's gone?
Kind of, yeah.
Oh, okay.
Yeah, is that, they talked about the strings have a vibrational frequency, and things with similar vibrational frequencies can interact with each other.
Okay.
But there are so many different frequencies out there that there could be whole different sets of stuff just at different frequencies that we can't interact with.
Okay.
And that gravity was strange in that it could interact with the various ones. So, who knows? There could be other things out there, and that could be dark matter, but it doesn't know.
OIC has come back to say some smaller galaxies don't appear to have dark matter, DM, right?
Yeah.
Because it might have been stripped off by collisions with other larger nearby galaxies.
Yeah.
But, interesting. But you still have a galaxy shape after a time.
Right. But they might not be spinning as fast as they would if they had the dark matter. But also, one of the things that I saw was showing real deep field galaxies, so really old galaxies, that some of them didn't appear to have the dark matter. Now, something
but they still have the spiral shape because...
well, most of the older ones were globular.
Globular, okay. That makes sense to me, and we can talk about why in a minute.
Yeah, but
remind me of the Shapiro experiment.
Okay, so we'll see. It's still an open, still open for debate.
Still a mystery.
Yeah,
like so many things.
Yeah, and now, like I said, they are creating experiments to try to show that dark matter, dark photons, might exist.
Cool.
But they don't. Yeah. Oh, elliptical galaxies.
The term is elliptical galaxies.
Yeah.
Okay.
They haven't quite formed a disk, but they are.
I wonder if like the mass would come back at some point, so it would be more galaxy shaped. I don't know.
Yeah. Well, and
so many things.
Here's the thing. Galaxies generally have, at least in the nearby neighbors, galaxies have a supermassive black hole in them. So it's quite possible that, one of the theories is that galaxies are the accretion disk for black holes. But don't know. I mean, you can see a correlation, but you can't call it causal until you know enough.
Oh, okay. I think it's they used to be spiral, but are old, heavily merged galaxies.
Ah.
Okay.
Okay.
Okay. Interesting.
Mm-hmm.
Do you want me to talk about the Shapiro experiments
sure.
now? All right. So I was part of a group called the Reaction Research Society. I went to a number of their meetings, and they would show different things periodically. You can find these online right now. I just call them the Shapiro experiments. And what he did was this was mostly for liquid. They were experiments about liquids, and he would have this viscous liquid in a vessel, and in the middle of the vessel would be a sort of a cylindrical thing. And what he did was he pulled ink through the viscous liquid and then spun the cylindrical thing, and it started to change the liquid into the line he created started to change, and it would become this kind of like a spiral galaxy arm. And what was interesting too was when he brought it back, it was a straight line again. So I was like, oh, isn't that interesting? Because you get that shape, what we see as a galaxy, because of this mass of viscous liquid. That's exactly what we see there. It's that spiral, arm, that arm of the galaxy that we're looking at. Did we get more? More fun, people? Okay. What'd you add to this thing?
Those are the links for, so I just posted the links to the original article and the wiki article.
Cool.
And,
all right.
Yeah, let's just see something.
You want to go back to the?
Oh, let's go back.
Okay. And he switched pages on this too, so.
I'm going to post this link too, because this is to an
it's
abstract.
A little hard to see on these, I noticed.
The anomalous magnetic moment of the muon. And this is one of the things that the dark photons as a theory can possibly explain why there's, there's something, quote, wrong, unquote, with the magnetic moment of the muon. And so this paper doesn't say anything about dark photons, but it does explain what's wrong, what the problem is, and that that dark photons are supposed to help explain. So I'll post that one as well.
Cool. Thank you. Oh, interesting. I think, because I didn't do that, but they're banned. Wow. We got a big deal fan here. They're going to send SWAT to our house. I love it. Guess we'll have to explain what happened. Cliff says, can you get hacked on this platform? As it looked like.
No.
I think someone's just creating an account and just leaving comments.
Yeah, every time we ban them, they create a new
No, we
account.
didn't. I haven't banned any of them. I do a hide and put them in a timeout because I don't mind if people come and talk to me. And then I see that it's banned. And then I'm like, oh, I didn't do that. See, watch. I'll bet they're going to just
There's probably an algorithm somewhere that whacks them.
Yeah, cow these nuts. That's not me, man. Woman, whoever you are. All right, so I think they're going to disappear. We'll see. Did you have more?
No.
Oh, okay.
So.
You want to go to this?
Yeah. Yeah.
Okay. So back to us. Some stellar events this week, and we're talking September 29th through October 6th. On September 29th, that's tonight, it's the full harvest moon, and the moon is on the equator. September 30th, the moon is at ascending node. October 1st, Jupiter and the moon are in conjunction. And because it's the first of the month, I want to remind you that you can get a nice free download from skymaps.com. And I do like to look at the Farmer's Almanac synopsis too for you, because there's some cool stuff in here. It gives you an overview of the month, basically. Let's see. Venus now, a dazzling morning star, closely meets Leo's blue star Regulus on the 8th and 9th and is best seen in the east around 5 a.m. Yep, I can attest to that. On the 14th, an annular solar eclipse sweeps across the western U.S. Always use eye protection for this ring of fire eclipse. Venus in Leo all month reaches its greatest angular distance from the sun on the 23rd, so it'll be the highest in the sky. It's already pretty darn high. With its 46 degrees of separation, making the morning star truly eye-catching. Yep. The 28th finds the full moon barely sliding into Earth's shadow, creating a 1% eclipse visible mainly from Asia. From the northwest U.S., its penumbral portion may be visible, but a penumbra rarely alters the moon's appearance. As a consolation, on the same evening of the 28th, the full moon closely meets Jupiter in a conjunction. I always like to look at that part. All right. So let's see. That takes us to October 2nd, Uranus and the moon are in conjunction. On October 4th, another globe at night project begins. I actually set my timer for this one because I want to get out there and do this. This goes from the 14th through the 4th through the 13th. And the objects you can look for in the southern hemisphere are Grus or Pegasus. In the northern hemisphere, you can look for Cygnus or Pegasus. And the idea here is to go out, look for these objects, and report what you see through the app on your phone or through their website. October 5th, the moon rides high. And then on to October 6th, we're back to the Friday night show. I'm going to do a profile, find out who I'm talking about in a minute or two. Find us Fridays at 9 p.m. Pacific time on the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel. It's also the last quarter moon.
And AC has the muon moment is just not what current CDM theory calculates it should be. And just like the vacuum energy calculation is way bigger than what it is actually measured. Yeah. Okay. And
we gotta get you on our show, AC.
Yeah. And that's
so smart. I love it.
Yeah. And so dark photons can fill in the gap for the muon moment, or there's something wrong with CDM. And that makes people unhappy. Oh.
No, I don't know what that is. That doesn't look right to me.
Okay.
Another comment that I don't know what.
Yeah. Okay.
If you're in Thousand Oaks, great. And say hi. That'd be a good start. Okay, sure. All right, you're up.
Okay. Other events and activities. World Space Week is October 4th through 10th.
Oh, yeah, I'm sharing screen for that.
Yes, you are.
Here it is.
The theme this year is space and entrepreneurship.
You want to do that link? Let me add that link to the
let's add the
comments so you can see it for yourself. All right, there it goes.
Okay, and remember, Australia, you still have time to name our rover. Although for us, I should say name your rover since we're not in Australia. But that they're actually calling it Name Our Rover.
That's the name of the contest. Yeah, Name Our Rover.
So entries close October 20th, 2023, and the winner will be announced on December 6th, 2023. The chosen name will be engraved on the Australian-made rover that will head toward the moon as early as 2026.
So exciting. I actually saw something on Facebook about it again today. So if you or someone you know has done something interesting involving space exploration, science, or astronomy, we'd love to share our live. Join us again next Friday, October 6th. I'm going to do a profile of Richard P. Feynman. I actually admire him very much. I know he's gone now, but I really, anything I've ever read, saw videos of, whatever, I enjoyed a great deal. Oh, we got another comment from AC.
It's great if the CDM is not wrong and just not accurate enough to just like Newton wasn't wrong, but Einstein took gravity to places Newton never dreamed of. Yeah. And it's quite likely that, like Newton, it works in the macro or most cases, but there are edge cases where it doesn't. Just like Newtonian physics kind of breaks down in certain edge cases, and even Einsteinian breaks down a little bit, which is where we get quantum stuff that, so there's cases where maybe, we need a theory to explain the other theories, to explain why certain theories don't exactly match, figure out where the edges are and try to stitch them together.
And Cliff says, and there are a few new space type movies coming out. Ooh, cool. Okay. And what by NASA? Oh, I don't think I know about that one. We did a review of space movies not too long ago, right? And I was like looking for them. We'll watch the trailers like they have one after another. Anyway, tonight's trivia question is, what is Richard P. Feynman probably most well known for? Join us again next week. We'll answer and see if you got it right. Oh, AC came back with general relativity is undefined in the inside of black holes. Yeah, there's a lot of weird stuff that happens there, I think.
Well,
we don't even know.
If you take Einstein's equations, you have to divide by 0 in a black hole.
Okay.
And so that's where his stuff breaks down.
This is too funny. Reading these comments, bro. Check your damn front door. It's right here.
Don't hear him knocking.
Yeah, cool. Thanks. All right, so we're gonna do a shout out. AC, Cliff, Janie, Dawn, our fans out there who we will not name. Who else do we have? Scott was here. Gosh, there's so many. Did we get them? Did we get everybody?
Let's see. What about, you said Janie?
These are too funny. Yeah, Janie.
Yeah. Okay. Yeah. Looks like we got everyone.
Thanks so much for joining us. We really appreciate that. And the rest of them we just kind of laugh at. Alrighty. So, folks, you have a great week. I'll see you next Friday. Good night.
Good night.